I think it's possible we're live, although I never am quite sure. So I'll wait for someone to say it's live in the chat and then we'll continue, I guess. But it's nice to see you all. We've been doing a few of these live streams recently. This is like the third one in so many weeks, I think. Something like that. Oh, good. Good. I'm glad it is live. I am having a little tipple today. So last time I was drinking coffee, today it's whiskey from a wine glass. So that's not all whiskey, by the way. This is like that much whiskey and then that much water and ice. So it's not full-on whiskey. But it's still got a bit of a taste. I like whiskey and water, it's good. Anyhow, not that I condone drinking in any form. We're looking today at the binary crap clock. God, I can't talk already. Brilliant. Yeah, the binary crap clock. That's it. This is so this is a little symbol I drew for the original crap clock, and so I've decided it's going to be called the binary crap clock. Now, as many of you will point out in the chat, it's not exactly binary. It's not all of these numbers in a binary form. It's each decimal in a binary form, but it's still readable. And if you were to buy a binary clock these days or find something on the internet that's a binary clock or claims to be, it's generally this. A binary clock with the, what's that date since January 1970 or something like that, whatever that's called. Epoch date, that's it. If you were to have a binary clock displaying that figure, it would be huge. So this is the way that most of them do it. Anyway, let me look at the chat quickly. Now I've done my little introduction and see what people are saying before I ignore anyone, and I don't want to do that. Hello to Peter, Gary, Dave. Hello, Dave. We've got Mobius Horizons, Colin, Cheap Vlog. We've got Ian Sumeda. Sumeda. I don't know how how to pronounce your name, but I did give it a go. Yeah, so all of you guys are here, which is lovely. What I wanted to do today is just talk about the crap clock, I guess. Whoa, oh dear, hang on a minute. We might have to. I'm dropping quite a few frames. Let me have a look and see if I can change something in the output to alleviate the problem. Let's find out if that changes anything. So I've dropped the, I'm like jumping around windows, sorry. I've dropped the bit rate. So hopefully that changes things, who knows. Anyway, this is the crap clock. So the binary crap clock. Someone said in the last stream that we should always have a crap clock on stream. So we've gone for this. Now this is my board without the ground planes. Did I put them back in or did I just take them out? I've taken them out for now. So you'll notice there's lots of air wires here. Now, if you remember on the last stream that I did, there was a switch up here and that switched off the LEDs so that you could have the clock still running, but the LEDs wouldn't be powered on, because I think they can be quite distracting. But it's just these ones that are quite distracting, really, the seconds. So I've taken that out, and it's simplified my circuit no end. And I've also replaced my resistors with SMD resistors, which is a bit of a it's a compromise. I didn't really want to do it because I liked the idea of it being mostly through hole, and I've already purchased these 4, 5, 10 ICs, but in a dip package. So I've got loads of them. I don't know, about 25, 30, something like that. And because I'd planned to use them, but the board was just too big. It didn't make it cost effective to have a board that large, which was about double the size of this. Didn't make it cost effective to have a board that large based on how much money I would lose out on these ICs that I'd already bought. So I've gone to some 0805 resistors, and hopefully you'll forgive me for that. I did want it to be really easy to solder, mostly through hole. Let's put these ground planes back in, if I can remember how to do that. Yeah, I think I do. Hang on. There we go. So this will be our top ground plane. My grid is really tiny at the moment. No, that's the wrong thing, David. Sorry, I haven't done this for a while. Is it this one? Polygon? I think this is it. Yeah, it is. Polygon. There we go. Right, name that as GND. And we want ground on the bottom as well. So let's just rat's nest that up so you can see that it's changing. And then I'm just going to bung in the polygon for the bottom layer. There we go, that's better. So, although it doesn't look as nice, admittedly, as without the ground layer. In fact, I'm going to get rid of them, but I just wanted you to see that the air wires have now gone, plus they really bug me. So all we have to do to get rid of those is, I think we can just move them, but we can also just rip it up. But this is our board layout. Now, you'll notice that some of these wires are pretty thin. In fact, some of them aren't accurate at all. What's going on there? That should be, no, it's 8. Damn. Sorry, I'll get back to where I was before. There we go. Okay, let me just jump back into the chat. So what I wanted to talk about was some of the design choices I've made, some of the routing on the board, because it's gone a bit messy, and where I'm going to buy this from, and how I'm going to source the parts to make it a kit. I did mention before, and I'm sticking to it, that I won't be making a profit on this. All it's going to do is cover the costs, if it even gets to the point where I can sell it on Tindy or whatever the things are that you sell things on. So let me just look at the stream. Looks clean, good. Mario says, why not KiCad? Well, I have a license for Eagle, so I can use it. I work in an educational institution, and so I have a license. I don't particularly like KiCad. I like the way I can create parts and navigate through the library in Eagle, but they're all much of a muchness, really. Lots of these different softwares are very, very similar. The ones that cost money, like Eagle, have limitations on board size for the free version and things like that, but this board here wouldn't actually go outside of the limitation for the free version, as far as I know. It is pretty, it's not small, but it's small enough. Caraman says hi, hello. Who else do we have that's arrived? Chris Leach. And SMD is fine, especially if so stuff 085s are easy enough. Yeah, I hope they would be. I tried 1206 on here, but actually it was almost as bad as having a through-hole LED. Through-hole resistor, honestly, they're about as long, so it made sense to go for these 0805s. Yeah, Peter, you're right. 0805s are pretty easy to solder by hand. You tin one pad and then push, essentially, the resistor onto it and solder the other one. That's exactly the way I do it. I've got a cable in the way of the rest of the chat. Hang on. Yeah, decent tweezers. Need to get decent tweezers. I used some really, really bad ones for a while. They might even be on the desk still. I'm not sure. I can't see them. But they were the ones where you you sort of press, and then pressing opens the tweezers and then releasing it grips, and they were awful. I lost so many little SMD resistors and LEDs that have just pinged off somewhere because of those things. So just try and get some sort of manual ones, not the ones where they have the reverse pressure. Yeah, magnifying glasses are difficult. Yeah, I don't really like using them. I mean, I've got this one which someone kindly donated, which has lovely LEDs. You can probably, I don't know if you can see that, if you can see me through there, that probably, I don't know what it's doing there. It doesn't, it's a bit dirty, but it's very good for examining small parts. So I like to use it to look at parts on the board, but I don't use it for soldering. I think that's very much a by eye thing. And soldering, you don't need to be sort of grain of sand accurate. The solder will just flow onto the parts you need it to go to. Yeah, it is really good, Gary. You're right. So yeah, let's have a look at the design choices I made on the board. And I think we'll start in the schematic, actually. That's probably a good place to start. Where even is the schematic? Oh, sorry. I'm looking at the board layout. I need to be in this bit. There we go. And it's turned up on the other side of the page, right? So, God, it's really long. What I should have done is moved everything. In fact, we can do that now, can't we? So let's... No, I like them where they are, actually, because it replicates the LED layout. So I'm not very good at this part of designing a PCB because my labels are awful, and you really, really should label things correctly. I started off really well, like down here, labeling things as hours, tens, singles and stuff. And then I just realized I wanted to add a few extra bits. So I just threw them in there, which is a mistake. You should always label properly. Otherwise people after you can't really figure out what you're doing. Also, when you work really late on it at night, you won't remember the next day what you've done. So this is a little bit of a mystery to me. I sort of know what's going on, but I don't know why I made the choice to put all these switches in one big bundle. Silly, really. So I've got a main reset switch here. Now this resets the entire clock. So every one of the reset lines is connected in a way. So I found that actually connecting the reset lines is really bad, because then these automatically reset each other based on the number that's there through my, where is it? Ah, no, it's separated into weird things. The 4081, which is a an AND gate. It's a quad input to something AND gate. Basically, it's two inputs for each one of the AND gates, and there are 4 of them on this IC. I can't remember how you meant to exactly describe that. Let's see if it says. Quad 2 input AND gate. That's what it is. It's a CMOS chip, and I should be able to get it in an SMD version. I can't remember how many pins it has. I think it only has 16. So anyway, we've got a reset switch. We have this one's called switches. Oh yeah. So in order to increment the count once you've reset the clock and turned off the internal 1 Hertz pulse, then you can use 2 switches to set the time. One is a 250 Hertz, 256 Hertz pulse, and that will fly through the time really, really quickly, 256 seconds for every second that you press. And the other one is an individual step. So it's hopefully this is debounced. As I recall, that's how it looks. So hopefully. And then we've got the turning on the normal 1 Hertz pulse. Now, originally it had been designed so that you would just switch this thing on at midnight. But I decided we probably needed a different approach to it. It's not perfect by any means. And the problem is that we don't have a microcontroller here. There's no method where I can hold down the button and then the count slowly increases in speed. That's not going to work. It's going to be a stepped thing. So 256 Hertz, so 256 seconds a second, which means you could fly through time really, really quickly. So that's what 256 divided by 60 is. Where's my calculator when you need it? I'm going to just use my phone. Pretend that I'm doing this in my head and I'm really impressive. 256 divided by 60. is 4.2 minutes per second you'll be able to fly through. So the idea is that you set your hours and your bigger minutes, and then you step through with the smaller digits with this individual counter. And you can press those pretty quick, so hopefully it will be appropriate. Who knows though? Yeah, who said that? Peter says, I love the lack of microcontroller. Well, yeah, that's the whole point really. So I didn't want there to be a microcontroller in it. I wanted it to be a challenge to create. I deliberately didn't look up anyone else's CMOS clocks from the 1970s, because I'm sure there will have been a lot. I didn't want to figure it out through that. So this works on the breadboard. Will it work on a PCB? I have no idea, but we're going to find out together. So this is my current schematic, and this is going to be the very first prototype. I've replicated and improved upon everything that's on the breadboard. But that said, there are still a few issues that are sort of hanging over my head. Some things I don't know about, and there'll be some things that I don't know about as well, of course. But I've got some pins on my CMOS chips are not connected. They're not grounded out. They're not pulled up to high or anything like that. So they're sort of floating. And I know that's bad for inputs on CMOS chips, but I don't know about the outputs. So I've left them, and we're not going to do anything with them because I don't want to add any more parts. I don't want to put any resistors in there to pull up or pull down. So we're just going to see if it works and see if it's stable. So I know that inputs are bad if they're left floating, but I don't know about outputs. We'll find out. Brain Freeze is here. Hello. You didn't miss an awful lot. You just missed me rambling on, which I do most of the time. Right, so let's start from the beginning, shall we? So we've got the seconds, the tens. Sorry, you can't see some of this, can you? So yeah, you've got the seconds, you've got the tens, the single minutes, the tens of minutes, the single hours, and then the tens of hours. Now this is a 24-hour clock, so that tens of hours is going to go up to 2, and the single hours will go up to 9. Whoops, jumped across there. Now, in order to make this work, we've got a 4081, which is an AND gate connected. Now, on the single seconds and the larger seconds, this one's controlled just 0 to 9. That's how that chip works. It goes 0 to 9, and so that's fine. And its carry out signal, just here, the carry out is our tens line. So that's telling my tens line to carry in. So every time it clocks over, it carries in. And it still uses the IC clock for the clock pulse. So it will change every time that changes. So that means when it gets to 9, the 10th pulse is when this goes over to 1. And then the problem here is we can only go up to 5 on the seconds. Well, technically 6, but we only go up to 5. So you get 59 seconds, then it's 60, and it carries over. But we can't really do that because we can't reprogram the way that 4, 5, 10 works. It's not even reprogramming. This has got loads of little transistors in there and stuff. So we can't change the way that works. It's already essentially wired up for us. So it's a much more complex version of what I'm doing with all these gates. So what we're going to do is take the outputs of this, and because this is binary, we start with 1, 2, 4, and 8 on those gates there. And so this gate here is 1, this is 2, and this is 4. So what I can do is say when this is 2 and this is 4, so when it reaches 60, so when this is carried over from the 59, throws it into 60, we're going to reset that chip, and this will carry out to mins. So this is our mins seconds. So this is just the mins single. So this is our first single minutes. And so we've got our input, carry input, which is minutes. So the carry in doesn't quite work, as in it's not a clock pulse. If it's high, then the IC clock can carry through. So it will only count when carry in is high. So that's essentially how it works. It's an on-off switch for the count, essentially. So it will start counting off this one here. So we've got our AND gate triggering that. well, triggering the reset over here. And it's also got a pull down. Oh, actually, this is probably a good thing to explain. So our reset line, they're all commoned. All of the reset lines on all these chips are commoned under reset. Now that's connected to the reset switch that I showed you before, which is on our board up here. This is our reset switch, main reset. It's probably going to go on the bottom of the board. At the moment it's on the top, but it doesn't really matter where it is. We can just flip it around. But it is sort of wide up now. Oh, I'm missing out on the chat, sorry. So we're talking about the reset line. Let me read chat quickly and then see. Electro Noobs there, hello. Press button, what does Brain Freeze say? Sorry. Press button, slowly increments. Count increment. If increment is greater than 15, increase speed, one button. Oh yeah, sorry, yeah, I didn't read your next one. Yeah, no microcontroller at all in this one, which is great, because you know that other crap clock, that's still not finished because I haven't finished the darn software for it. So the reason that hasn't been released to you all, I mean, there's no point just having the PCB and the like all the design files for it if you don't know how to program the microcontroller to control everything on the board. So once the software is finished, it does the time now, but the buttons don't do anything. You can't set the time without programming it again. But it does keep the time because it's got one of those DS3231s on it. Anyway, I'm getting off topic again. Peter says, I had an LED clock in the 70s with a fast switch in addition to hours and seconds. Increment speed was 2 Hertz until you hit the fast switch, then it went to 256. Yeah, I had a look at being able to have extra buttons on here for the hours and minutes, but it would take up too much board space, really. Although, I mean, I suppose it's possible I could just increment the tens and then the minutes, sorry, increment the minutes single and those ones and this one, but then you just have to make do with whatever the seconds come out at. That's possible, but I think we'll go with what I've got for now because I know at least it works on a breadboard. So yeah, the thing I wanted to talk about was the reset line. So all these resets from here are commoned. Oops, you can't see that because I've got stuff in the way. There we go. So they're all commoned, but we've got a diode in there. Now, I've no idea what kind of diode this is. I just picked a diode that had roughly the right size for the schematic. So, I mean, it's a little bit big. It could be a lot smaller. It could be an SMD one. However, it's fairly fortuitous that it is a through hole because I'm having to jump different layers quite a lot, to be honest. So I'm fine with it being through hole like that. It's okay. So I've chosen that size, but that's just a general size for a diode, isn't it? So I'm happy with that. Anyway, it goes. So the main reset line goes through that diode and into reset. Hopefully the output on this 4081 is high impedance enough. And we've got a pull down on the reset line. So that stops it doing anything silly. So yeah, it's got this reset there going through the diode, which means whenever this triggers the reset, it's not going to reset every other chip, which is nice. And then further on, we've got minutes single. That's just connected straight to the reset line before this resistor. It can be reset whenever the button's pressed, but it doesn't have a carry out thing, so that we have to worry about because it can go to 9, so it's not a problem. But then the minutes tens, that has to go to 5 again. So we've got the same circuit. These are almost replicas. So you've got minutes tens just, where's minutes tens? Minutes tens just there, and seconds tens. If you'll notice, they're pretty much the same. In fact, they are the same. So yeah, apart from just having different signals going to them, they're exactly the same circuit, which makes it really, really easy. It might be a Schottky diode. I don't know. It just looks right on the PCB layout. It doesn't particularly matter in the schematic. It's just going to be any kind of signal diode would be fine. It doesn't really matter. So yeah, the minutes tens and the seconds tens, exactly the same circuit, just different signals going in. And the single minutes and the single seconds, they're exactly the same as well. So we've got most of our work done there, really. Next up, we've got the hours single and the hours tens. Now these are joined together. They're essentially, I mean, I really shouldn't have a line here. They should just be the same. And the reason they're joined together is because the hours act in a very different way to the rest of the clock. We have the hours which can go to 0, 1 and 2. And the hours single can go from 0 to 9, which is fine. But when the hours at the single one are 4 and the hours on the tens are 2, we need to reset that clock. Now, it's 1 second past midnight, essentially, at that time, but not 1 sec. Yeah, it's 1 pulse past midnight, but by the time this thing refreshes and you get the next pulse on the other side. But so when this hits 23 hours, 59 minutes, the next clock pulse will send the hours to be 4 over here. So 1, 2, 4. So on this line, and it will send the hour, and the hours over here will already be 2. So it won't trigger on 1 and 4. So it won't trigger at 2 in the afternoon on the 24-hour clock, but it will trigger at 2 and 4. And then that will reset this one and reset this one here. The other digits down here have already done their job resetting. They're not connected to this part of the clock. So essentially we're just dealing with this little bit of workflow here. That's largely it. The only other part of this circuit that is important is this one. This is the one that actually keeps the time. This is the one sending across all those signals. Lots of people complaining about my diode. Sorry, yeah, I just chose one. It didn't matter to me. It could have been a resistor, but I just wanted it to look a bit like a diode. Hello, Adam. It's not a drinking stream. This is orange juice. No, apple juice. That looks more appropriate. I guess you wouldn't want a Zener with a low reverse voltage, as it could let the pulses pass through the other logic. Yeah, it could. So no, it's going to just be a normal diode. I just couldn't find the right one, so we just used that. Anyway, this one, completely unlabeled, which is nice, isn't it? Is the timing circuit. So this is a 4060D, which is a divide by IC. It's a CMOS chip. And it's essentially, it divides by, where does it start? So 256, 128, 64, 32. Is it divide by 32? I'm sure it's not. I'm sure it's divide by 2, divide by 4, and so on. But essentially, what it does, it divides down our crystal, which is here, the 32768 kilohertz crystal, essentially a watch crystal. That's why they're used, because they divide down really, really easily. It's going to divide that down, and these are our loading resistors and capacitors. And then it's going to use a 4027, which is just off screen. There must be a thing on here for moving the screen around. I'm sure there was. I don't know. Let's do that. Hang on a second. There we go. I'm just doing it really badly. So over here we've got a 4027. Now this is a JK flip-flop. Essentially, you can turn something on, the next signal will turn it off. So we're dividing our pulse again by 2. So I'm using both sides of this JK flip-flop. So we have our pulse, it's a 2 Hertz pulse coming out of the 4060 here, and then I essentially only take one of those pulses. That's the gist of what's happening, and we get the 1 Hertz pulse out. And I'm also taking out a 0.5 Hertz pulse. Now I'm actually throwing out these pulses onto some pins on the board, a 2 Hertz, 0.5 Hertz, 1 Hertz. I don't think I'm bringing out the 256 anywhere, but I just thought it might be nice for people to have them. It's for no other reason than monitoring, or you could use it to trigger something else. You've got a 1 Hertz pulse essentially, and it's very accurate. So that's our circuit. We've got various bits for some ICs. That's just a power breakout that I've invoked those pins. And we've got a little, down here there's a tiny bit of decoupling. I didn't know where else to put it. It's just on the power line. So I just put it there. So 5 volt on ground, and I've put it near where the power pins are. So it's just in there, but it doesn't particularly matter. Anyway, we'll talk about some of the choices I made in laying out the circuit now. And some of the things that you probably do as well, some of the problems that you experience. But I'll just jump into chat and see if anyone's asked any questions. Some talk about the diodes. Oh no, that was before. Not a problem using a different symbol on Eagle. I do it quite often. Dave doing some moderation there. You can use your middle mouse button to move the screen. Can you? Oh, yes. Chuck, you're a genius. Thank you. I appreciate that a lot. Jim says, years ago when I was allowed, I made a programmable countdown timer and could enter whatever time you wanted. And when it had counted down to 0, it rotated a servo 180 degrees. That's cool. Servo was attached to a pen, and when it rotated, okay. Right, well, we'll move on. Anyway, so this is my current layout. It actually hasn't progressed too much more than when we did the stream before. I wonder if I've still got a picture of what it looked like before. No, I don't. You'll have to go and look at the other stream. You'll be able to see it doesn't look too much different. It's smaller now. I made the decision I needed to make the board smaller. And the reason was that 5 were going to cost me $36 to make. And that was a bit much, or it was a bit more than I wanted to pay. And so now they're around about $29, so a lot less really. If you consider I'm going to try and make 30 to 40 of these, and I've got to give a couple away because I sort of promised that I would. I'm going to have to find out who I told that I would give a free one to. And there's someone I like on YouTube, FranLab. Does anyone watch FranLab? I like Fran. I think she's really, really clever. Absolutely fascinating. I really like the sound of her voice. So I like listening to the stories and stuff. So I like that. And so I thought I'd send one in to her and see if she fancied making it. She likes old, like CMOS type stuff. So I thought it might be fun. If she doesn't make it, doesn't matter. But still, what was I? Oh yeah, I made it smaller. So what I had to do was revert to using SMD resistors, which is something I didn't want to do. I wanted it to be all through hole. And the reason I wanted to do that was because I was breadboarding it as through hole. And I thought, well, if I'm breadboarding it as through hole, I want it to be as close as possible to my original design. And I want it to be easy for people to solder. And so I made that decision, and then I've just had to go back on it because it's just too costly to make a board that large. Even getting it printed in China from companies like OSH Park, who they're a US-based company, I think, but they actually print their boards in China. As far as I know, I may be completely wrong. And then PCBWay is another one that I'm looking at, same as PCBs.io, but PCBs.io doesn't accept the new Eagle files, unfortunately, so I'm gonna have to create Gerbers, which is annoying, but still. So I decided to make it smaller, and that meant cramming these components in a bit more, choosing different sizes of components, overlapping somewhere I didn't before, and using an awful lot more vias than I had previously. Now, you'll notice there's still a lot of space in here. If it was going to be a really crammed board, I'd probably use traces that were a lot smaller. You can see there's a lot of space between some of these traces, but not between the ICs. There's not an awful lot of room. But in modern electronics, it's absolutely not unknown to be able to fit 2 or 3 traces down the side of one of these chips, maybe even more than that. And I'm staying with a 2-layer board. So what I've done is just made some decisions based on how much I can afford to pay for these boards and how much I really want to put into routing these boards. Because honestly, this took me about an hour and a half to route out. Every time I design a board, I will give it a go first. I'll put all the components roughly where I want them. And that meant that, you know, the LEDs stretched all the way up here before. I wanted to have more space between them. I wanted people to be able to design their own enclosure for it if they wanted. And so I wanted more space between them and the ability to have sort of a taller clock. The original design was that this was a vertical clock. So this was on its side and it could still be that way. It would just have to be turned the other way. Now, I sacrificed a lot of those sort of preferences because I wanted to make it cheaper. And the reason I want to make it cheaper for myself is also, it means that if I'm going to try and sell it at cost, that cost has to be pretty darn low. And the components on here alone are going to cost a lot of money. So the cheapest, absolute cheapest place at the moment I've found is PCBWay. Now, if we measure this board, I've got a measurement tool on here somewhere. I could never remember what it looks like. If we measure it, so measure from there, please, to there. You're on the wrong layer. Measure from there to there is 76.85. So that's 77, isn't it? And so let's measure from here to, stop doing that, computer. So measure from there to here is 49.94. So what was it, 77? Is that what I said? Yeah, 77 to 50. 77 millimeters by 50 millimeters. So not big by any means. How large is like a credit card or something? Let's see if I've got something in my pocket. I think it's larger than that, certainly. What have I got that doesn't have all my details on it? I don't really have anything that doesn't have all my details on it. I have a Nectar card. So this is 33, so double the width of that essentially. Oh no, that's inches. Hang on a minute. Let's redo this because David doesn't know what the size of anything is. So that is 80 centimeters, 84 centimeters by 53. Bloomin' heck, that's going to be small, isn't it? So it's going to be about the size of a credit card. Okay, maybe we can rethink this. That doesn't seem right, does it? Does that seem right? I thought I'd figure this out before I started this stream. I thought this was going to be David Watts explains his binary clock thing, but it's not, is it? I've just realized actually it might be a lot smaller than I imagined. Is it? So 50 millimeters. Is it in millimeters, first off? Grid, millimeters. Is it 50 mil? Hang on a minute. It is 50 millimeters by 76. Interesting. Okay, it might be too small now. And I was wondering if I had room for mounting holes. So maybe we'll make it a little bit bigger and put these 2 mounting holes that I put on there elsewhere. We'll come back to that at another time. I thought it was larger, but I think I've shrunk it down much more than it used to be. Yeah, interesting. So yeah, I made a lot of decisions to shrink this board down, including when I started designing. I started designing the bit of the circuit that I knew really well, which is the 1 Hertz timer. So I've sandwiched 2 ICs on either side of the board here. This is the 4060 and the 4027. This section here, this small section there, forms my 1 Hertz timer, essentially. I probably have one in a drawer here somewhere. No, I don't know where it is exactly, but I had already designed this circuit, so I knew how to do it. And then what I did up here was add on my switches, which alternate that the IC stuff. And then I thought, well, I need to add the rest of the stuff in now. And so I spread these out really, really far and made it comfortable for me to route. And I think everybody does that when they first design something, and they make it comfortable. And so what I needed to do was I needed a design challenge in order to actually do something that wasn't really, really easy, to learn something or to stretch myself essentially. So I created some limitations, and one of them was that I wanted to be able to sell the thing, whatever we end up calling it or whatever it ends up being. I wanted to be able to make sure I can sell it for less than £15. And so that is my goal, and that's the restriction, that I have to be able to sell it for less than £15. And if that means I can't include the LEDs in that, then so be it. People can use their own LEDs. Essentially, if you look at this, we've got a 470 ohm resistor. Each one of the outputs on one of these 4510s can cope with around 10 to 15 milliamps. Now, if you just take that output, you can throw it into a transistor and drive whatever you want. So people can drive their own LEDs or anything they want to, really, off this. All they just need to do is plug into these LED pins and change the resistors, I guess. But so that's one of the decisions I made, was that it cannot be more than £15, because I wouldn't pay more than £15 for a crap kit. And now knowing it's less than the size of or it's smaller than one of those little credit cards, then definitely I wouldn't pay £15. God. Okay, let's have a little look at the chat. I've been banging on about money and how much things cost for ages, sorry. Where's the microphone gone? Oh, it's there. I'm like showing a bit too much chest there. Oh yeah, I spoke about FranLab, didn't I? So some of you guys watch Fran. Yeah, I really like it. It's a very mature channel. It's not necessarily funny or anything, but honestly, she's just very clever and I really enjoy. I like watching anyone who's really experienced in electronics, honestly. Dave Jones is funny, wildly annoying sometimes, but I really respect the man. He's so clever. He knows loads of stuff, and he's not afraid to admit when he's got something wrong or he doesn't know something. I love all of the, what is that? Solar Road stuff. God, love it when he analyzes all of that stuff. It's great. But yeah, his Aussie sense of humour, I never quite get. So it's the, he's got loads of sayings, isn't he? But anyway, we'll move on from that. So some people mentioning some PCB places, JBC PCB, and they offer 10 boards for $2. No, really? Easy EDA is super cheap. $2 for 10 by centimeter, 100 millimeters by 100 millimeters, 2-layer. Hang on a minute. I think PCBWay does something like that. Let's have a quick look at PCBWay. So PCBWay, if I put my dimensions in, which was 77 millimeters by 50 millimeters, 2 layers, number of pieces. Let's say we want 5. And then quote now, I'm using Edge. So it's telling me it's $5. That's not really a massive difference, is it? Not really worried about that. But the bit where it starts to sting is when you add postage in. So actually it's $30 for 5. I could change this to, let's say 10. Still only $5 for 10. And so we're still only going to pay $30. So it would be $3 each, which makes it pretty cheap. That's all right. Let's say I want 20. Okay, we're looking at, what, $2.5 each. That's good. But I need to print off a small amount first. And so I'm probably going to go to OSH Park for that. The reason I need to print off a small amount first is going to need to test it. I could easily have made a mistake somewhere along here because I breadboarded this up. I didn't design it first. I literally just sat down at a breadboard and made it. In fact, I've got some paper sketches which I looked at, and I could have done all manner of things wrong here. So there could be some things that aren't right here, or I might not have thought about the noise in the circuit properly. So I need to do a cheap prototype first. And I'd like to include some of that cost in the cost that I put the boards out for, because I don't want to be out of pocket, because I'll never want to do it again. So I want to make sure that I cover the costs of doing the project. And so that will probably include the prototyping process as well, as it would do any business or any venture really. You don't start something in order for it to fail. So if I can break even with it, then I'll keep making them and more people can have them, or I'll start another project and we'll do a different one. But if it turns out it's too difficult and it's just like a lost leader essentially, then I won't do it. I just can't afford it, unfortunately. So anyway, yeah. So yeah, PCBWay is sort of a similar thing to those, I guess. They're just going to charge quite a lot for delivery. Moonbrony, hello. Is that a My Little Pony thing? Just an idea, but if you're wanting a small footprint and a through hole, couldn't you make it one board above another? That's an interesting idea, and one I had thought of, but it meant that I would have to have two boards printed. So I did think about it, and then decided that I'd rather have the cost saving of just having one board. The footprint itself isn't too bothersome, it's just the cost really. And having two runs of one PCB is more expensive than doing a slightly larger PCB. So it's just a bit easier. Electronic sounds really cheap. They make Eagle files or just CAM files. You know, Dave's asking about whether the place that Electron Ash suggested takes Eagle files. I really love that about OSH Park, about PCBs.io, lots of those kinds of places where they just take your Eagle board. So you don't have to worry about anything you've messed up in the sort of CAM process or whatever else you do, the Excelian sort of process for getting out your Gerbers and stuff. So, or your gerbil files, as some of my electronics technicians friends like to call them, and I end up calling them that too. Yeah, if you can just go straight from Eagle files, that's great. I love that. It's brilliant. Yeah, Electron Ash says it's very easy to do in Eagle. Yeah, but it's just a worry, so I prefer not to have that. But I suppose you're then worrying about how they're processing your Eagle files as well. I'm really far behind on the chat, sorry. Wolfgang, hello. Make it like a credit card and call it the credit card crap clock, or credit card clock. I like that. You know, I might steal that. Thank you. Dave says, by the way, LEDs on the other side means you can move the resistor close to the legs. That's very true. Yeah, at the moment, I don't need to shrink it anymore. I can't shrink this bottom section here. So this is too difficult to shrink in the horizontal at the moment without putting more of these ICs on the other side of the board. And then I just have to route on the back side of the board anyway. And it's just getting a bit too difficult. Now, I don't mind a challenge. I love a challenge, in fact. I could probably do this with all SMD LEDs and make it probably half the size again, but I'm happy with the size because otherwise it's going to get difficult for people to solder. So I think it's okay for now. Confusion over whether OSH Parks do get made in China anyway. I think they just get reshipped. Yeah, I think they do get made in China and get reshipped. But that's fine. Chinese boards are great. The quality is amazing. PCBs.io is my favorite by far. Not by far. OSH Park are brilliant. They're about on par, but PCBs.io is cheaper. But they don't take the new Eagle files yet, so I'm not going to get anything printed with them until they do, really. I'm going to contact them actually and see if they're planning on changing. or if they can take the new ones and they can process them, just not automatically on the website to give you those awesome thumbnails. Actually, that's one of my favorite things, you know, on OSH Park, when you get the sort of the preview of what the board's going to be, I'm like, my heart's like pounding a little bit, getting excited about getting it done. So we'll probably do that in a minute and have a look. What's that? Sorry, the chat. There's too much chat. I'm not telling you to stop talking, it's fine. Electron Ash. I was wondering, is it the Acorn Electron? Is that what your name's about? Dave is great, but he's not so keen on remote computers. I think we've spoken before. I'm sure we have. What's amazing new clock? Or what time is it? That's pretty good. I like that. I've just decided to brand it with this guy. So he's on the crap clock because I wanted to try my hand at sort of freehanding a little picture on the solder mask, and so he's going to be on. He'll be on everything I do, I guess. So we might as well just make it a thing. Yeah, I'll take a look at the Easy EDA ones. I'm going to shop around. We're not making a purchase today, but I thought we'd take a look at it. So the other decisions I've made here on this board, apart from shrinking it down and changing out some resistors for these SMD ones, and hopefully 0805 is easy enough. If it's not, then we can look at some other ones. Is different trace widths. Now, normally I don't do that because most of the stuff I deal with is low current. I don't need to worry about trace widths. Sometimes though, trace widths end up meaning that you have a voltage drop, and that can happen with longer traces. Turns out this board's actually really, really tiny. Didn't know, thought it was a lot larger. When you work it on a screen like this, it just looks bigger. I'm sort of imagining these LEDs being a lot larger. Actually, it's tiny. So it's not going to matter, but you can see this trace here is pretty small. That's a fairly small trace. That's about as small as I usually go on traces. And then we've got slightly larger traces down here. And even here, you can notice that I started using a smaller trace. This is a larger trace here. So this is probably, oh God, I've changed my thing. I usually use mil. So this is 10, whereas this should be 8. Yeah, we're not going to change it, we're going to leave it like that. It's perfectly fine to have different size traces. As I said, it can help with current and with voltage drop. So, but this is like the width of my fingernail, so don't worry about it. So that's one of the choices I made, but without needing to, because I didn't really think about how large the board was. But I thought it was bigger, if you can sort of get my meaning. In my head, these are like through-hole components. I don't know, it was silly. So we've gone for standard available chips. Chips are components. So these are these tactile switches. They're just normal ones. You could pick them up for, you know, 100 for a penny or something. I think I've got a bunch anyway, so they're all right. These are just standard slide switches. They should be okay to pick up. They're the sort of single pole, double throw type. And then everything else is just normal. That's 33 picofarad. That's not even the right footprint for it, but it will work. So 104s, they're going to fit into a normal component hole, so that's fine. And then we've got a couple of headers here. I did think about moving these together so that I don't have to separate them, so that's something I might do. But essentially, this is your 5 volt and ground. Thought maybe it's best to have those separate from these output pins that you can use, which are 5 volts, 2 hertz, 5 volts, not 5 volts, 0.5 hertz, 1 hertz, 2 hertz, and ground. Oh yeah, the reason for that, I added an extra ground there because I really wanted to look at it on a scope. So I wanted to just scope it out so we could see what how accurate the clock was. And I thought that'd be fun for people to do. And the other thing that I made a decision to do was to use the 4510 and the 4081 in SMD format. Now that's going to make it more expensive, unfortunately. Right here, and here, and here, and here. The rest are downstairs, I think. Oh no, wait, there's some more there. So I bought lots. Oh, there's more over here, look. So I bought lots and lots of these, 4510s, and these ones are, these are 4060s. I don't know if you can see them. I'm trying to hold them up. Bought lots of these from sort of Chinese sellers on AliExpress, so they might be crap. Who knows? But that would fit with the clock, wouldn't it? But I bought lots of them, so I've got lots. So I kind of wanted to make it sort of through hole, but no, we've had to go for SMD components. They're not going to be hugely expensive. In fact, we could take a quick look at how much they'll be. So let's look at a CD4060. So this is going to give us all the CMOS chips. Just show me the results. There we are. So if I just bring this over a bit, you'll be able to see all of that stuff. So this is just Farnell. It's not going to be, it's just representative of the kind of pricing I can expect. It's not going to be the cheapest, but actually in the UK I can get it delivered free, so maybe it will be relatively cheap or worth getting because I can get them quickly and reliably. So these are sourced from good component suppliers generally. So we've got the CD4060BM. I've gone for the D, but it basically doesn't matter. I don't know what those letters at the end mean. They're usually something strange, like it will cope with certain temperatures or whatever. But there are several of them here. We just want to make sure that it's, that picture will not go away. It's because I'm using Edge, isn't it? Oh no. So this is SOIC, so we need to make sure. Let's have a look at our schematic and find out what package we've put down. We've used SO16, so that's SOIC16, that's fine. So it's this one here. So if I arrange it by price, oh, well, that's by the most expensive, isn't it? So I click that again. Is that right? No, hang on. Sort up. I don't know which one to press. There we go, that's better. So 4060 supply, each supplied on a full reel. So you have to get a larger number there. This again, you have to buy a large number. So this really catches you out. So this one looks like they're 23 pence each. That's pretty good. I can do that. Although that still adds up to a couple of quid, I would have thought. But delivery charge is £15.95 because it's in the US probably. So we need to go down to these ones where you can buy them each for 37 pence each. How many do we have? 1, 2, 3, 4, 5, 6. So calculator's coming out again because I don't know how to do maths. 37 times 6. So that's already £2.22 if I were to buy them from here. Now, I've got no doubt in my mind there'll be cheaper places to get them from. In fact, this bit down here, look, if I buy 100, which is kind of a lot, but maybe I don't need to buy 100. We can get in multiples of 10 for 30 pence. So it's going to make it even cheaper. So as long as we buy increasing numbers, then we'll be all right. So if you all commit to buying 20 right now, that'd be, no, I'm kidding, don't. So I'm going to have to look at all this stuff. And it's very worrying, the amount of cost it takes to do these small projects. I'm absolutely sure people make a loss on Tindy and things like that. So let's say I want a 4027. I need one of those for each one of these kits. It's that button there, isn't it? Okay, so the cheap, a £3 re-reeling charge, of God. So the cheapest we can get it for a single IC is 43 pence. That's a lot of money for that one IC. However, we can get it for 31 pence if we buy 5. That's fine. And I might want to buy, will I want to buy 50? No, I doubt it. So I'll buy 5, let's say. But, you know, it starts to rack up the cost. So 4081, this is our quad input AND gate. So this one is, so that one there, 42 pence. That's the wrong shape. That's cheaper, but you know, the cost just goes up and up and up. And what else do we have on here that we need to worry about? Resistors, not really. They'll be very cheap. LEDs, they'll also be very cheap. In fact, resistors I'd probably get from China or somewhere like that. They can hardly go that wrong. So yeah, and I think ICs are going to be the really expensive part. The buttons are going to be cheap. The LEDs will be really cheap, and the resistors will be pittance, so will the capacitors, so I don't need to worry about that. But the ICs, getting the board done, postage, packing, all of that stuff I have to think about. And I'm at that stage now where I need to actually start thinking about it. The board is done. The prototype is ready to go. I'll be sending it off this weekend after I've been over it a couple more times. I might rip up all the signals and reroute the board one more time just to make sure that it looks similar to what it did before, that I'm making the same choices over and over again. Because if that's the case, then at least I think I've made the right decisions. And then we'll send it off this weekend. I'll post some pictures on Twitter of like the board layout and stuff of how it's actually going to be. So I'm excited. I really am, honestly. I don't know if have any of you guys made a kit? I think Dave, have you done stuff like this before? Dave Darko, that is. I'm sure he's done something like that, but he's designed a lot of PCBs, probably more than me. I don't get most of mine printed. So I've got a huge project list in here that I use to pull ideas from, but I haven't had them all printed. I've just designed them and then I just pull it out. Let me jump back to chat and have a quick gander. I'll also have a sip on this because my throat is getting a bit dry from all the talking. Oh, hang on a minute. I'm like super far back in the chat, but I was just reading something and it really caught my eye. So all PC, so this is Electron Ash. I spoke about it earlier, whether Oshpark actually get their boards made in China and then ship them back to the US and then ship them out from there. But apparently, it's basically speculation, but I don't know how they can possibly do it so cheap. But Owlsight, hello Owlsight, he says all PCBs shipped from Lake Oswego, I don't know if that's right, in Oregon, and are fully manufactured in the United States. That's fantastic. I mean, I've got no preference over the US and China in terms of PCB manufacturing, but I like that they're doing that and they can do it at the cost that they do it at. I mean, it's not actually much more expensive than me going to PCB way in terms of shipping. That's really interesting. We've got Electrocity 2000. Your voice sounds like a continuity announcer. Oh. Oshpark produces in America lead-free boards which are manufactured in the United States and shipped for free to anywhere in the world. That, yeah, the cost of shipping is pittance, isn't it, to them? So it's great. The mascot reminds me of Clippy a bit. I don't know who Clippy is. Do I? Is that the Microsoft clip, the paperclip? I'm just sorry, I'm still reading through your comments. I'm not reading them out loud, so just bear with me a second. Someone wants one, as long as I sign it with a kiss. I tell you what, I will sign it for you. but I don't know, that's a bit weird, isn't it? So expensive buying from normal sellers. Need 2 electrolytics recently. Bought 100 from China for the price of 4 from UK seller. Oh, I know what you mean. People on eBay, you'll notice this if you've ever bought anything from eBay in the UK. I feel like I'm really low in my chair. It's because I slouch when I'm lazy. In the UK, you'll have people that work for a company that has perhaps an account with Farnell or something similar like that. And either they'll be able to buy through that account and pay from their own card or whatever, but they may get stuff for free, or they might get it VAT free. And so they just buy things from Farnell and charge £1 more than they would get it from Farnell for. And Farnell deliver for free if you have these business accounts, or if it's over a certain amount, I think. So people really rinse you for that here. But I'm sure they do everywhere. I'm sure that happens all over the place. Electro Noob says, I use AliExpress way too much. Mate, I do it all the time too. I haven't bought anything from there for a little while because I've been saving some money. I splurged a lot on that camera a little while back, so I'm just sort of trying to not spend so much money for a little while. Although I did buy an Amazon Echo, and that the air duster for my computer. That's such a lame purchase because I wanted to buy this book called it's The Book of Dust. It's by the same guy that did it's too late now and I'm tired and can't think. Northern Lights. What was his name? That dude. Anyway, I bought his new book because I'd read all the previous ones, and because I was buying that, I wanted to get like free delivery to an Amazon locker, so I just bought this duster thing. Anyway, stupid purchasing habits. Colin says, why not take orders for, say, £15 each, and then buy components based on quantities from orders, the finalised cost? I could do that. That's a fairly good idea. I might have a think about that. What I really want to do is just keep it as low a cost as possible. I think this design with the manufacturers I've looked at for parts, that is really cheap Chinese places where I have no idea where the parts come from, for capacitors, resistors and switches and header pins, then I think we're fine. I think the biggest cost is going to be the PCB and the ICs on the board, and then everything else is postage, depends on where it's going to go, but because it's so small, it should be relatively small, hopefully. Right, I think, I don't know how long I've been going for, about an hour. I sort of said it would only be an hour because I've only had sort of an hour's worth of stuff to talk about. But shall I do a little recap? Is that a good idea? Yeah, why not? Okay, so what we've talked about today is the schematic. I've been through the sort of function of it, how it works, why I think it's final now. So why all of these individual parts work, why I'm happy with the 1 Hz timer, and the flow of digits across here and the carryouts and the reset lines, and my switches, and I think they're okay. I'm not totally sure, but I'm not too worried because you can always reset it at midnight. And I've talked about some of the design decisions I made here, and I've listened to some of your ideas about what I could maybe change, and I'm going to revisit this at the weekend before I send it out, so I'll probably reroute the entire board before I do. Although this was a real hard slog, an hour and a half routing this board, like going back on myself, figuring out where I could make decisions, and I desperately wanted to keep, who was it that told me to do this? I can't remember. Somebody, I'm sure it was someone at work, and they said that you should make a decision as to whether you're having the traces on the top go vertically or horizontally, and then try and stick with that and try going all vertical with your top layers and all horizontal with your bottom layer traces. And I tried to do that, it's not perfect, mind. We've got a bottom layer trace here. It's because I need to keep my grounds open that way, so I just decided to do that. It's not getting in the way of anything. And I've talked about how I wanted to make it smaller, to make it more affordable and choose different parts. and how it's still open for people to mod it, which I think would be great. If people just use this as the source of their signal to fire up their LEDs for whatever kind of massive binary clock they make, or one using little filament lamps or something like that, then that would be absolutely fantastic. So you can just sort of peg onto these LED channels, and you can still get 10 to 15 milliamps out of each one of these outputs. If you bear in mind that only like 3 of these LEDs are ever on at a time, it's not a lot of current going through the 4, 5, 10, so it's all right. And it's not a lot of current in the whole circuit, really. So small currents, and you can drive big things, really. So yeah, oh, and it's got mounting holes. I sort of didn't speak about these. I put them there because I think I should probably have them, and people might tell me off if I didn't put any mounting holes in. But I never put mounting holes in pretty much any of my PCBs. I don't think there are any. Are there any on the... Here's the crap clock. Look, it's basically forever on my desk. Yeah, there are 2 mounting holes on the crap clock. In fact, oh, that's my glass. I don't know if... Is this on autofocus? No, hang on. Let's change it to autofocus for a second. Properties, configure video, autofocus, save. Okay, so this is the crap clock. It should autofocus on this thing. Are you going to? Oh, is it because I didn't click OK? Yes, it's because I didn't click OK. Just, come on now. Okay, focus, focus, focus. There's the little guy, can you see him? So that's the same little symbol I put on my other one, but this one also had mounting holes, really small ones. Can you see it above the clock bit there? And there should be another one down near where it says crap. So yeah, those are like, just, okay. Oh, it worked. Okay. So yeah, I've got mounting holes, and I decided I would use them. So it is something I've added this time, but I don't know if it's going to happen on all of my boards. Probably won't, because I mean, I make these boards because I want to learn how to make them, and that's it. I don't really use most of them. So I've got loads of boards floating around where I've done it as a proof of concept and then never really used it again. So I never had to mount it. The exception being the USB volume control board that I made. That I use every day. I've got that at work at the moment hooked up. So I use that every single day. Although you can buy like things like that these days. I just like the fact that I made mine. So that one I had to jerry-rig some kind of mounting system. Anyway, I think that's it for this stream. I think we've gone through everything that I wanted to talk about, and I appreciate your feedback on like where I'm going to get them printed, where good places are to get components, and where certainly bad places are, and perhaps how we can possibly make this smaller if I want to at the weekend. I could certainly put these 4.510s, a couple of them at least, on the other side of the board, and then shift them underneath a couple of the other ones, and then shrink it in, possibly. I'm frightened of doing that, mind, but we might do it. Anyway, if anyone has any questions, now is a great time to do it, because I'm about to click that end stream button. I know you guys are at 15 seconds behind, so before I say I'm going to close the stream, I'm just going to sit here and drink my apple juice. I need a name for this guy as well. So if anyone comes up with one, put it in the comments after the stream. Nice names, mind. Nice names. I don't know, crappy? That's not a nice name, is it? Plus, this apple juice is making me a bit tipsy now. Right. Thank you very much for joining me. I think that I've left it enough time now. So I don't know how many people are watching. Any idea? In fact, I'm going to jump to the watch page, and that will tell me how many people are watching. 36 people watching. That is brilliant. Thank you very much for joining me. I think there's been a few more than that over the time, and you've all gotten bored, I'm sure. But I will let you know what's happening with the binary crap clock after the weekend. I'll put some pictures on Twitter, so look out for those, of the board final design and stuff. All right, how do I stop the stream? I always forget this part. Hang on, not that bit, that bit. No. Oh, for heaven's sake, I don't. Is it this bit? Who knows? You have a great evening. Goodbye.